Welcome to this session of Gemini Safety Training. The entire purpose of this training is to avoid getting injured while working in a machine hazard zone. In the past, we've referred to this simply as lockout tagout, but we need to take it even further and provide emphasis on blocking hazardous energy that we can't effectively lock out. We'll define what a hazard zone is. We'll discuss when lockout and/or blockout is and isn't required, and possible exceptions to the lockout rule. I'll cover the proper steps to conduct an effective lockout, and we'll cover the requirements for what's called group lockout. We'll talk about shift transfer of lockout and why that's so important. And finally, we'll cover the removal of locks owned by other people. There are many forms of hazardous energy associated with equipment that we use. Hazardous energy is any form of energy that, if allowed to release, can cause an action that can seriously harm a person. Here are 9 of the most common sources of hazardous energy: electrical, alternating current, direct current, batteries, capacitors, and static electricity; pneumatic, airlines, cylinders, reservoir tanks; rotating equipment such as shafts, flywheels, fans, saws, saw blades, gears, chucks, arbors; gravity, suspended objects, air and/or hydraulic cylinders losing pressure can come down on us; springs, springs under compression or tension, they can move objects that can work in a bad way against us; hydraulic, pressurized hoses and/or cylinders can retain extremely hazardous energy; heat, such as ovens, cutting tools, welding, they can all be hot enough to cause injuries to us; lasers, pretty self-evident, they can cut and they can burn very fast; chemicals, valves opening or pumps pushing these chemicals, if they're hazardous, if they're pushing them towards us, that can be a problem. A hazard zone is any part of a machine or process that can cause serious injury to a person. And we want you to consider things such as spinning arbors, blades, belts, collets, cutters, drill bits, shafts, anything like clasping or clamping mechanisms, crimping, compactors. We want you to think of pneumatic cylinders and vices, or hydraulic cylinders. Think about rollers that can pinch together, dies that can cut or form parts, shears for cutting, hot surfaces, lasers, chemical processing tanks. Each of these can contain hazard zones that can hurt you. Now that we've gotten some basic definitions covered and you understand what a hazard zone is, let's watch as Gemini tool and die maker Tony Frank walks us through the locking out and blocking out of his Haas CNC milling machine. The first step in conducting any lockout is to review the procedure for that machine. This is a good time to make note of the tools you'll need to conduct a lockout and/or blockout of the hazardous energy in that machine.
Pete, I'm going to be locking out the house, so don't mess with it.
Okay, Tony.
Now Tony's going to install a blocking device that effectively holds the milling head up, thus preventing it from dropping down and crushing him. Shut down the head using the control panel. Disconnect the electrical supply by turning it to the off position, then apply your lock and tag. Disconnect the airline, install the cover, lock, and tag it. Finally, verify the machine is dead by trying to restart it at the control panel. In this lockout example, Tony has protected himself from 3 different sources of hazardous energy by blocking gravity, by disconnecting and locking out the electrical supply and the pneumatic or the air supply, and by bleeding away any residual energy, if any, and by verifying the machine is harmless by trying to restart it at the control panel. Verifying the machine is harmless is the most important step in lockout. Now let's go through the steps to release a machine from lockout. The first step in releasing a machine from lockout is to review the procedure for the correct steps and the correct sequence of those steps. For some machines, the sequence is very important.
Pete, I'm gonna put the Haas back into service.
Okay, Tony.
All right.
Remove any blocking devices that were installed. Remove the lock, then the cover, then reattach the airline. Remove the lock and turn the disconnect to the power on position. Before turning the machine on, first check for tools or supplies that may have been left inside or on top the machine. For large, complex machines like our extruders, be sure to check that all coworkers are outside the hazard zones and are at safe distances before starting up the machine. Throughout this training, you've heard me say over and over, if you can't lock out a hazard, you have to find a way to block the hazard. I'd like to show you a few examples of how energy, and in this case gravity, can be safely blocked. Many of you already protect yourself at home when you block the weight of your truck or your car by placing it on jack stands. These are great tools for blocking gravity. And maybe you've noticed semi-trailers that are supported by a trailer jack. The jack keeps the trailer from tipping over when a forklift drives onto the front end or when a heavy load is set at the front end. Here we can see a scissor lift table that's equipped with its own blocking device installed. It's the red bar. Normally the bar is retained out of the way by a bracket. When needed though, the table is raised to its full height, the bar is released into the vertical position, and the table is allowed to settle down onto the blocking bar. Now before climbing under the table and into the hazard zone, this table and other machines like it, they must be blocked in a manner that protects the person working beneath it from the hazards associated with gravity. Here we can see another scissor lift table that's been retrofitted with a blocking bar of our own design. It's the yellow bar stored in the base of the machine. Notice in the photo on the right how the blocking bar has not only been relocated to the left into the blocking position, but how a locking pin is inserted in that blocking position to keep it from popping out of that track. Now you may need to employ a similar locking retainer or pin or clip to keep that blocking device in its intended position in the machine you're working on. Here we're looking at a 1,000-ton injection molding machine that has a blocking device that automatically places itself into a blocking position just prior to the access door opening. In this photo, we're calling it the blocking clamp. In the video that will follow, you'll see how the blocking clamp drops into position on the jam bar just before the operator opens the door. With the blocking clamp in that position on the jam bar, the big cylinder can't accidentally close the mold as long as the access door is open. This is a good example of safety features built into a machine that automatically protect operators from injury. They provide what we call safety coverage. So now that you've seen some examples of how we can effectively block hazardous motion, it's up to you to ensure that whenever you can't lock out a hazard, such as gravity or springs, then you must safely and effectively block that hazard. If you don't have the correct tools available to you to correctly and effectively block out known hazards, then stay out of the hazard zone until you get the right tools. What's the difference between a production task and a non-production task anyway? I mean, if the task is done by a production person and not an office person, then it must be a production task, right? Well, no. OSHA considers these kinds of tasks to be different, and as such, they have different rules. For the purposes of lockout, it's important that we understand the difference between production tasks and non-production tasks as we interact with equipment. Now, production tasks are actions that directly affect or change the product. For example, cutting or drilling, sanding or forming, polishing, and painting. But non-production tasks are actions that support the production tasks. For example, setting up a machine, or tool changes, or cleaning, maintenance, and repairs. Think of, think of those as preparing the machines to do the work. The tasks on the left side of the screen are product focused, meaning these tasks convert raw materials into final product. Production tasks are typically very repetitive and there's a rhythm to the work. For example, I load the machine, I drill the part, I unload the machine, I repeat. There's a cycle, there's a rhythm to the work. Tasks on the right side of the screen are machine or equipment focused. These tasks themselves don't make any product, but we do these tasks on the right side to ensure that the machine runs as expected. Now, understanding the difference between production tasks and non-production tasks is critical to understanding why lockout is required and why sometimes it's not required. Which machines or tasks must be locked out? Well, it would be easy to say that any machine that has a lockout procedure attached to it must be locked out. Unfortunately, history has shown us that over time some of the lockout tagout procedures have been removed or fell off the machine but were never put back. We need you to understand the reasoning behind the answers to the following questions so that even if a procedure is missing from a machine, you still make the correct decision about protecting yourself. Questions like, which tasks require me to lock out and why? And which tasks am I allowed to do without locking out a machine and why? The answers to those questions can be found in this chart. This chart is a combination of the OSHA standard that deals with the control of hazardous energy. Now, there's a lot of information here, but don't worry. We'll break it down into bite-sized pieces that will make sense to you by the end. When somebody asks me if a lockout is required while doing certain tasks on their machine, the first question I ask them is, are you working inside a hazard zone? Remember, a hazard zone is any part of a machine that can cause serious harm to you. If the answer is no, then relative to this chart, they're in the green zone and locking out or blocking out that energy is not required. If you are not reaching your body into a hazard zone, the machine can't hurt you. Locking the machine out or blocking the hazardous energy is not required. Being outside the hazard zone does not require locking, blocking, or tagging the machine. If you're reaching your body into a hazard zone, the machine might hurt you if it were to suddenly start up, cycle, activate, move, or shift. Locking the machine out and or blocking the hazardous energy may be required depending on the conditions. What kind of conditions? Since we're not concerned about the green part of this chart, let's focus on the area inside this blue box. And there we go. First, let's look at the left side of this chart. There are some tasks where even though you're reaching into a hazard zone, locking out or blocking out the machine still isn't required. Here we grabbed the bottom left corner and rotated it clockwise, making it easier to read. The OSHA standard tells us that locking out or blocking out is not required even while reaching into a hazard zone if each of the following three conditions apply. Number one, if the tasks that we're doing are routine production tasks that are integral to actually producing the part or product, and number two, if there are fully functional safety devices in place, such as interlocks, proximity switches, and light curtains that stop or prevent hazardous motion while we're reaching into the machine, then safety features called out in number two here act as a kind of a safety umbrella for us. So if these features are in place and fully functional, and number three, if we're limiting ourselves to these tasks, the tasks shown here which carry limited exposure, yes, we can load and unload parts without locking out the machine. We can do minor changing of tools such as drill bits or cutting inserts that require simple tools like using an Allen wrench or a collet key. We can do that without lockout. We can also do minor cleaning of machines such as reaching in with a broom or a rake without locking out. But if we have to climb into that machine or climb onto the table bed, then we have to lock it out. There's usually an exception to every rule, and lockout is no exception to the exception. Sound confusing? Unfortunately, there's a fair amount of confusion throughout industry about this exception to lockout. OSHA does allow exceptions to the lockout rule, meaning you don't have to lock it out, but only if these four conditions exist simultaneously. Number one, the machine has only one source of hazardous energy. Remember, consider pneumatics and hydraulics, spring, gravity, heat, static electricity. And number two, the source of energy is a plug style or a manual coupler, for example, an air hose, that you can actually unplug or uncouple. Number three, you can maintain complete control over the end of that cord or hose while doing your work on the machine. If your work takes you more than 10 feet from the plug, then you'll have to do a lockout, tag out, block out. Number four, the machine can have no capacity to store energy such as a reservoir air tank or air cylinders or electrical capacitors or springs that could be in compression or tension or where gravity is a factor. Only when all four conditions have been met may you avoid locking out or blocking out that machine. Knowing what you do now about the single cord exception to lockout, do these machines qualify for that single cord exception? The answers will appear on the next slide. A drill press with a single 120 volt flexible power cord and a plug. A stroke sander with a flexible power cord and plug and an air line. A bandsaw that's hardwired to 120 volts. A portable hand drill with a power cord. A bead blasting cabinet supplied with 120 volt power and an air line. A table saw hardwired to 120 volts. An electric taping box machine that incorporates air cylinders. A drill press with a single 120 volt flexible power cord and plug does qualify. Yes, it does not need to be locked out as long as you unplug it. A stroke sander does not qualify since those machines have two sources of power, electricity and pneumatic. A bandsaw that's hardwired does not qualify since it's not a plug style machine. A portable hand drill with a power cord does apply. It does meet the exception and does not need to be locked out. A bead blasting cabinet does not qualify since it has two sources of power, electric and air. A table saw that's hardwired may only have one source of power, but it's hardwired. Does not qualify for the exception. Must be locked out. A box taping machine that incorporates air cylinders and electricity does not qualify. That has two sources of hazardous energy. So let's review what we've learned so far. If we're working outside the hazard zones of a machine, we have no need to lock it out. If we're working inside a hazard zone of a machine, we may or may not have to lock it out depending on the kind of task we're doing and if we're covered by that so-called safety umbrella. Now let's take a closer look at the right half of this chart, the yellow and the red areas. And now let's rotate the tasks in the blue box up and to the left so that we can more easily read them. OSHA has very clear language regarding the kinds of tasks that require lockout. If you have to reach or climb into a hazard zone to unjam a machine, you have to lock it out and or block out the hazards. For clarity, I'm going to repeat that. If you have to reach or climb into a hazard zone to unjam a machine, you have to lock it out and or block out the hazards. Now, one way to avoid locking out a machine during a jam is to avoid going into the hazard zone. Can you unjam it with a tool such as a broom handle or a hook, some other tool? If the machine jams frequently, wouldn't it be better to engineer a solution to that jam rather than having to shut the machine down all the time? Consider that as your best solution. Unjamming machines is the number one cause of fatalities in the factory. Be aware though that if you do reach into an energized machine with a tool, use only tools that can't pull you into the machine if the tool itself gets caught. Avoid tools with hook-shaped handles or straps that would go around your wrist. Anytime you have to, number one, bypass any safety device like an interlock, a proximity switch, a light curtain, or number two, remove a guard, or number three, place any part of your body inside a hazard zone to perform tool holder changes, to perform service or maintenance, to conduct repairs, or to do cleaning. If you have to do those things, then you have to protect yourself by locking out and or blocking out those hazards. Now it's time to look at just the two final columns on the right side that address setups and changeovers. Again, we'll rotate the tasks in the blue box up and to the left so we can more easily read them. You may be wondering, why did OSHA include setups and machine changeovers in the lockout standard? Well, the answer is because there have been so many injuries associated with these tasks that would have been prevented simply by locking out and or blocking out the machine. Setting machines up can be full of risks if you don't fully protect yourself. If, number one, you have to reach or climb into a hazard zone where, number two, you can be exposed to hazardous energy or hazardous motion, then the machine must be locked out and or blocked out. Now, some of you might be thinking, hey, I can't set up my machine if the power isn't on. I can do some of the tasks without the power, but not all of them. What do I do? If that's the case, OSHA expects you to complete the tasks that you can while the machine remains locked out, and then energize the machine and complete those final steps, but from outside the hazard zone. That's why the number 3 box is orange and not red, red indicating a full lockout. Doesn't this make setups and changeovers more inconvenient for us? Well, yes, it does. It clearly does. But you should know that Fred Oss, our company president, firmly believes that following the OSHA standard is the right thing to do, even though it takes more time. Your personal safety is much more important than any product that we're trying to ship to a customer. One of the frequent questions that comes up has to do with changing belts on a stroke sander. You can't change the belt properly without air pressure in the cylinders, right? Well, you may leave the air pressure on, but you must disconnect or unplug and lock out the electrical power for belt changes. Now this chart should make a lot more sense to you. If you're outside the hazard zone, there's no need to lock it out. If you're reaching or climbing into a hazard zone, you may need to lock it out. And it depends on several conditions. But when in doubt, just lock it out. If you're covered by the features of that safety umbrella, locking out is not needed. If all four conditions of a single cord or single plug exception applies, you can avoid locking it out simply by unplugging it. If the single cord exception does not apply while doing the tasks shown in the red cells, then you must lock it out and or block out the hazards. If a hazard can't be locked out, then you must find a way to block it out from contacting you. Blocking devices must be capable of withstanding the forces they'll be subjected to. Now that we understand when locking out and blocking out a machine is required, here are the basic steps for every lockout or blockout. Step number one, review the lockout procedure, gather your tools that you'll need. Number two, notify the people who will be affected by the lockout. Number three, go through the normal shutdown procedures at the control panel. Tripping a light curtain or punching an e-stop does not de-energize the machine. It only stops the motion temporarily. Step number four, disconnect or block each of the power sources. Apply a lock and a tag. Applying a tag with your name on it communicates to others who applied the lock. That way people who know who to contact if they need to have the lock removed. Before beginning maintenance, test it to verify there's no electrical current flowing. Number five, bleed away any stored energy within the system or block its motion. Things like air cylinders, air tanks, electrical capacitors, springs, objects that may have been lifted up that could come back down. Number six, attempt to restart the machine and activate motion to verify that it's inoperable. This last step is the single most important step in the entire process. Many people have been seriously injured even though they thought they went through the previous steps shown here. Unfortunately, some people mistakenly disconnect the wrong power source, and going through the verification step by attempting to restart it will show them that the machine is still live. Always verify. Here are the basic steps to remove a machine from lockout and put it back into production. Step number 1, review the procedure for the correct sequence of steps. The correct sequence might surprise you. Step number 2, notify affected employees that the machine is being restored to service. Step number 3, remove all tools, supply items, and any blocking devices that may have been left in the machine. Step number 4, replace and secure all required machine guarding. Step number 5, remove all locks and tags and reconnect the machine to the various power sources in the proper sequence. Step number 6, restart the machine using the normal startup procedure. Now, the most common problem with putting a machine back into service is when tools have been left inside. When the machine fires up, sometimes those tools become airborne and strike people. So always clear out the machine of tools and replace the guards before energizing the machine. If you've applied a lockout to a machine and you need to leave the building because your shift is ending, then you must hand off or transfer your responsibility to another qualified employee. They must apply their lock to the machine or box first, and then you remove yours. If you leave the building with your lock remaining on a machine, you might be called back to remove your lock. OSHA requires that any person who applied the lock also remove the lock. If you're called to come back to work and remove a lock, it's unpaid time. So never leave the plant with your lock on any machine unless you transfer ownership of the key by using the lockout key drop box, and we'll talk about that shortly. Before we talk about the lockout key drop box, let's cover the requirements of assuming ownership of someone else's lockout. Before you accept ownership of a machine that has been locked out by someone else, you must first review the lockout procedure. Then, verify that each energy source has been locked out or effectively blocked. Then, you must ensure that the residual energy has been released. And finally, verify the machine is harmless by attempting to restart it. 2 slides ago, I explained that you should never leave the building with your lock still on a machine and that you should transfer ownership to another qualified person. That's easy when shifts work back to back, but transferring lockout ownership from second shift to first shift creates a challenge since there's no face to face exchange. To do that, we need you to follow 2 steps. Number 1, deposit your key or keys in the lockout key drop box located either in the plant manager's office or in the site maintenance shop. And number 2, fill out the transfer form and leave it right there on the clipboard so that maintenance will see it. The lockout tagout transfer form looks like this. Fill in the date, your name, the location of the machine, the name of the machine that you locked out, and the reason that you left it locked out, and leave it right there on the clipboard. Not often, but sometimes more than one person needs to enter the hazard zone of a machine to do their work. When we apply multiple locks to a lockout device, like the hasp that you see here, we call that a gang lock. Locking out in this manner ensures that no one else will energize the machine while you are in there. Before applying your own lock to an existing lockout, you must first verify that the lockout itself was done effectively. First of all, do not attempt to verify while someone else is in or working on the machine. Ensure everyone is clear before attempting the verification step. Then apply your lock. Under normal circumstances, we must not remove the lock supplied by another person. Now, OSHA does make some concessions regarding lock removal, and we have to be very careful to avoid making critical mistakes. For that reason, only people directly authorized by supervisors or plant managers may remove the lock of another person. Before this authorization may be granted, we must first make every effort to contact the lock owner before cutting the lock off. Then we have to warn all affected personnel that that lock will be cut off and the machine put back in service. Then we're required to tell the lock owner that his or her lock has been removed prior to their returning to work. Last, We have to retain the completed form in the plant manager's office as a record. Prior to removing the lock of another person, the lock cutting authorization form must be completed and signed. And that form can be found on our intranet by going to Safety Environmental, looking for the SOPs, and then finding the Lockout Tagout SOP. You'll find that form there. Congratulations! You've made it to the end of one of our most complex training topics at Gemini. Here's what we've covered. We've defined what a hazard zone is. It's any part of a machine that can seriously hurt you. We've explained when lockout and or blockout is and isn't required. We've talked about exceptions to lockout and how if those four conditions are met, we can avoid having to lock out the machine as long as we unplug it. We've covered the proper steps to conduct an effective lockout and then how to put it back in service. We've talked about group lockout and how that protects multiple people simultaneously. We've covered the shift to shift transfer of lockout and using a key lockbox to transfer from second to first shift. Finally, we discussed the removal of locks applied by others and the steps that we have to take to ensure that the owner of the lock has been made aware. Remember, always protect yourself out there by rendering hazardous machines harmless before placing your body into a hazard zone. Be safe out there.